We made a difference. We made it together. We made it. Oil spills can cause a tremendous amount of damage to the environment and can have a devastating impact on plants, animals, people, and communities. One of the largest oil spills in history, called the Deepwater Horizon spill, occurred in 2010. It took nearly 4 months to stop, resulting in 5 million barrels of oil and costing billions of dollars in damage, cleanup, and fines. Experts say the area might never fully recover. When an oil spill occurs, it is the job of an environmental engineer to develop a system to quickly clean up the spill by containing and removing as much oil as possible. The cleanup must be effective and inexpensive, and have no negative impact on the marine life that will be impacted by the cleanup. There are 3 main methods that environmental engineers use to clean up oil spills. Number 1, skimming. The oil is contained by surrounding it with a long floating device. Imagine a gigantic circular pool noodle. It is then vacuumed or scooped up and put into tanks for disposal. Number 2, absorbing. The oil is surrounded and contained, then large sponges are used to soak up the oil. The sponges are then loaded onto boats and taken to shore for disposal. Sometimes, instead of using sponges to absorb the oil, once it is contained, it is set on fire and burned away. Number 3, dispersing. Eventually, wind and waves will mix the oil with the water, and it will form tiny droplets that will evaporate or can be eaten by microbes. Depending on the type of oil that is spilled, chemicals called dispersants, kind of like dish detergent, are sprayed on the spill to help speed up the formation of these oil droplets. The Deepwater Horizon spill had a terrifying impact on the plants and animals in the Gulf of Mexico. Each group will have to choose one of the species at risk and brainstorm 3 ways that an oil spill will directly impact that species. When designing your final cleanup method, you must ensure to take into consideration the species and ultimately what will help it to survive. You can choose one of the following: Fowler's toad, bald eagle, American eel, channel darter. The challenge. Your team of environmental engineers has been hired to design and construct a system that will contain and clean up an oil spill as fast and effectively as possible to ensure the survival of an important Ontario species at risk. The spill is too close to shore to burn it off, and this type of oil cannot be removed using dispersing. Absorbing and skimming are good ideas, but so far the methods used haven't worked. It's your job to develop a new system. First, you will have to make a simulation of the oil spill to test your ideas. To make the simulated oil, mix 100 milliliters of vegetable oil with 15 milliliters of cocoa powder. Then pour 250 milliliters of water into a tin foil pie plate and add the oil mixture. Simulate the action of wind and waves by gently mixing the oil and water. You will work with your team to brainstorm different methods for containing and removing the oil and saving your species. Experiment with the materials and test your ideas using your simulated oil spill. You can use stones or small rocks to simulate the shoreline. For your design, you can use any or all of the following materials. They are not all required: plastic wrap, fine screen, shredded wheat cereal, cooked rice, garden peat moss, small plastic syringes, eyedroppers, or spoons, rubber bands, string, yarn, glue, tape, scissors, balloons, toothpicks, popsicle sticks, skewers, paper towels, or cotton balls. Before you clean up your spill, dip a feather in the lake with the oil spill. How does it feel compared to a clean, dry feather? How does it compare to a feather dipped in clean water? Record your observations and set these feathers aside. You will use them to compare the effectiveness of your system. Then contain the spill and measure the visible area of the oil spill. How many square centimeters does your spill cover? After you have tested your design and removed the oil, dip a clean, dry feather into your cleaned up lake. How does it compare to the dry, wet, oiled feather from your previous observations? Measure the visible area and compare it to the original oil spill area. How many square centimeters does your oil spill cover now? You can rank your system's success using this table. Make any changes or improvements and redesign your system. Make sure to add your changes to your diagram and system description. Good luck!